For 36 and 37, we're looking at this rational function here, 5x squared minus 45 over x squared minus 4, and it's asking us about vertical and horizontal asymptotes. So let's think about first when we talk about vertical asymptotes. When do those happen is when we're looking at for a rational function. Usually things kind of look like this. Oops. And so at a vertical asymptote, the function would be undefined. And usually the reason why it's undefined for a vertical asymptote on a rational function is because the denominator is equal to 0. And so that's what we have to look for, is when is that denominator equal to 0? And so one thing we do have to watch out for, though, is sometimes we might have a denominator equal to 0, but it cancels out with a factor in the numerator. And so that ends up having a hole instead of an asymptote. So let's go through, factor these out to find those points where the denominator is zero, and then we can also go back and start canceling and simplifying if necessary. So for this function, we get, if I factor out of 5, this would be x squared minus 9. And on the bottom, this factors as x plus 2 and x minus 2, because it's a difference of 2 squares. And then the numerator here still factors more. So I have x plus 3 and x minus 3, because we, again, have a difference of 2 squares. And so we see nothing actually cancels out in our denominator or numerator. So these two values, or these two factors, we have to think about when would this give us a 0. So when would x plus 2 be 0 in the denominator? And when would x minus 2 be 0? And so we get two possible answers. That would be -2 and +2. And so those are where our vertical asymptotes are. Now let's talk about horizontal asymptotes. When would we see a horizontal asymptote here? Would depend on what's happening on the outsides towards the ends, specifically as we're taking the limit as x goes to infinity of our function, or as our x goes to -infinity of our function. Now, intuitively, if we're looking at just this function right away, you might remember from your algebra class that we can actually figure this out without actually doing the limits. And so this would be useful if we're just doing it for a multiple choice type of test. We can identify it by just looking at the highest power on both the numerator and denominator. And so if we ever have that the numerator is less than the denominator, then basically it's going to go to 0, because the bottom is going to go faster than the top. And so we're dividing by a bigger and bigger number would give us something closer and closer to 0. If we ever have that they're equal to each other in this case, then all we have to worry about is what are the coefficients, and we just take that. So here we can see that since x squared is on the top, x squared is on the bottom, we're going to end up with 5 over 1, and we could ignore everything else. And so the horizontal asymptote would just be y equals 5. But if we were having to write this out and show the calculus behind it, let's actually see how this matches up with if we were to take the limits. So if we were to talk about the limit as x goes to infinity of our function, 5x squared minus 45 over x squared minus 4, why does this method work is because let's do something that's going to make this an equivalent fraction. And the way we found this is if we just divide by the highest power. And so here we have an x squared, so let's divide everything by x squared. So in a sense, we're multiplying the top by 1 over x squared, and we're multiplying the bottom by 1 over x squared. And since we're doing the same thing on top and bottom, it's like we're multiplying by 1. It's not changing this. So this would give us the limit as x approaches infinity of 5x squared over x squared minus 45 over x squared over x squared over x squared minus 4 over x squared. And so let's see what's happening here when we take this limit. Remember, one of the key things that we saw is if we ever take the limit to infinity as we have it in the denominator, then it's just going to go to 0, because 45 divided by a bigger and bigger number goes to 0. And same thing with here. This goes to 0. So this is why anything that has a smaller power than 2, we can just know that it's going to go to 0 without even thinking about it. And here, these are just going to cancel out. So we're ending up with a 5 in the numerator and a 1 in the denominator. And so this gives us just 5. So again, as a equation of a line, we need a horizontal line, so it would be just y equals 5. And likewise, if we did the same thing for x going to negative infinity, we would get the exact same process where these two would end up going to 0 and the x squared still cancel out. And so we still get a horizontal asymptote of y equals 5. And even though you won't be able to use a graphing calculator as a quick visual to see what we were doing and what it was looking like, we found that the vertical asymptotes were going to be at 2 and negative 2, which we can see here on these two green lines here. We're hitting 2 and negative 2, and we see the graphs are approaching it on both sides, negative infinity on the left and right, and up here we have it's going to positive infinity. And then our horizontal asymptote of y equals 5, we can see this blue line going across, and the graph gets closer and closer in both directions, both in the positive and negative infinity to the y equals 5 line.